So the task that we just talked about was to take a JPEG and serve it via HTTP, which sounds easy. I mean, if it's like Apache or something, you just put the JPEG in a folder and you type in the URL with the folder name and the JPEG name, and it just magically just serves it, right? But Node doesn't work that way, because Node won't do anything you don't tell it to. Right, so it won't automatically serve any files, and that is by design. That's important about the way Node works. So if you want to serve what we call static files, you need to pull in a library to do that. In our case, we're not going to pull in a library. We're going to write it ourselves, so it's going to be fun. There's a few ways to do this. I'm going to make a directory. What should we call this? Assets. That's better. And I'm going to put this iPhone picture inside the assets folder. Okay, so I put my JPEG inside my assets folder here. So the first thing I'm going to do here on main is I'm going to read the data from that JPEG. So we need to import the file system module, and then the easiest way to read data is synchronously, right? So we'll just say let read file sync, and then how should I specify my file name, my path to the file? How did you guys do it? Like that? So dot dot makes sense, but it doesn't work. Because remember, when you're reading from the file system, it doesn't, the path doesn't go from the file you're writing the code in. It goes from your current working directory that you start Node from, right? Which is confusing. So what's a better way to do it? Path. So why don't we just join this thing using path.join. Now we can use dot dot. Is that better? Wait. Do you remember the magic underscore underscore dir name? The reason I say it's magic is because that's not a global variable. That's almost like a placeholder that refers to the current file that I'm in, the directory of the current file that I'm in, right? Remember that? We did that a few weeks ago. So this will take the current directory that I'm in, which is source directory, and then it will join that with the dot dot assets. And it'll correctly resolve all the dot dots. You with me? That gives me file data, which is, what data type is that? Sorry, somebody said what? Binary, what did you say? It's it's like a binary, but it's an object called a buffer, which kind of represents data, bytes, right? So we can make our own buffer, by the way, by just calling like let f equals new buffer. So what this will be, if I do this, is that's the byte representation of the string hello, which is a 5 bytes of binary data, right? But in this case, we get the buffer given to us from read file sync. And then what I want to do down here is I want to check the request URL. Did you guys use if? Switch is fine. Switch is fine. Okay, so if the request URL is like files iPhone x.jpg, sure, then we'll like do this. Let's make this a 404 and say not found. Okay. And so here, we're not going to write a string anymore, right? Also, our content type is not going to be text plain anymore, right? What is it going to be? Image slash? Like that? Should be the E in there, yeah. Okay, and then what are we going to write? File data. So done. I mean, this is your entire task. So if you do it the simplest possible way, it should look like this. Let's run this thing. Okay, so I'm going to refresh here, and what will I get? 404 not found. Okay. And then I'm going to change it to files iPhone x.jpg, and I get the picture, right? Simple enough. Sorry? Oh, it even resizes it automatically for me. That's really helpful. Anyway, okay. So, since I just had a look at Gemma's code, let's commit this first, and then let's look at how Gemma did it. Here, we did this read file sync thing, which is okay, because we only have one file, and it's not very big. In fact, this is really going to be fast, because every time I make a request, the server already has the data in memory. It doesn't even have to hit the disk. So the server is going to be super fast. But what if this file was really big, or what if we have 100 files that we need to serve? This becomes less ideal. Plus, not that it matters in such a simple program, but we're blocking the thread before we even begin the server, right? Before we even create this server, we're blocking here to make this call, right? Maybe not a big deal, but we could do better. So how could we do better? We could do a callback, right? So we take out the word sync, and we get this callback. Let me move this join also. Call it file data. Like that, right? Now, what I could do is I could just move all of this stuff inside there. Done, right? See what I did there? And this is no faster than what we had before, and it's no slower. It's basically exactly the same as what we had before, but maybe I feel better about my code because now I don't have a read file sync. I have a callback style. So this would work. But do you get why it's the same thing? Because previously we blocked the whole entire thread until we finished reading the file, but the whole entire thread was only the starting server, right? And now, instead of blocking, we just moved it inside the callback, so we're still not starting the server yet. We're still waiting till the file is finished reading and then starting the server. The only difference is we didn't block the main thread, but our main thread isn't doing anything else. This is the only thing it does, right? So, but maybe it's just good practice to not block the main thread. So let's make sure this still works. Still works, that's great. So then we might think, well, wait a second, maybe I could start my server and read my file in parallel, right? We could do that. Yes, we could certainly do that using promises, actually. That's a great idea. Yeah, we could do that. Let's do it. Like that, right? So that's our file data promise. What does our other promise need to be? Our other promise needs to be all of this stuff, right? So here, instead of just console.log server is ready, why don't we resolve server? So up here, what I can say is, I can say let server promise. Now, I guess at this point, I just do promise.all, and I have to pass in an array of 2 promises, right? And then inside of here, I can destructure the file data and the server. And then inside of here, I can attach my request event listener to the server. right? This is weird that the code coloring is a little strange there, but anyway. Okay, so then here I attach my, I could also say here, I guess I could say server's ready. Something like that, right? Okay. Yeah, that would work. This is complicated though, right? Maybe unnecessarily complicated. Plus, what if I had a bunch of different files? What if I had like 10 files that I want to serve? Then we're getting messy, right? We got to load all of them into memory. At least we're not blocking. Everything here is asynchronous. We're using promises, so we feel really good about our code. Maybe we could even use async await, right? But remember, we can't use async await. I mean, we can't use await here, right? I can't await file data promise. I can't do that, right? Why can't I do that? Correct, because I'm not in an async function. But I could make an async function called main. I could make an async function. I could move it in there, right? And then I just call main, right? So putting something into an async function is super easy, right? Yeah, we could do that.
The whole program in the main async function.
Like here?
Like the whole thing.
I could. Yeah, that's a great idea. That's a great idea. I could put the whole thing, right?
And then just execute main.
Sure. Yeah, Node will be happy with that. That's fine. And then I can use async await. That's pretty easy. Okay. What? But you know, besides all the async stuff, I mean, you know, async await, we could refactor this in 10 different ways, right? We could use async, we could use then, we could use promise.all, we could use whatever method possible callbacks, but ultimately, we're still reading this file into memory before we're serving it. And that doesn't really work well if our file is really large or if we have 100 files. But if we only have one file, it's super efficient because we don't have to read from disk for every request. What if we were getting 1,000 requests a second? This will be super efficient because we're not even reading the disk. We're just running from memory, right? So that's great. And that's partly why Node is so fast, is because we can do stuff like this. You couldn't do this with Apache easily, right? What if I don't want to read it ahead of time? Let's say I want to read this file within... Let's go back to what we had before. Okay, we're back to our read file sync, right? So we take this file path, we read file into data, and then later on here we kind of serve that file. But maybe we have a few different files. What could I do here if I want to read the file inside the request? This is what Gamma did, right? So Gamma, you did something along the lines of let's do something like this. So inside the request, and I like this approach, you say read file fs.read file path, and then we have a callback. And what does the callback get? Error in data. Okay. Like that. Or switch or something, right? Okay, so here we'll say if the request.url, we'll do this. So if the request is the home page, then we're going to do what? We're gonna do what we had before, which was like the whole something like that. Okay, so if it's the home route, then we'll do this stuff. Else, if it's this file's route, we'll read the file somehow, right? And I'll move this in here. And then lastly, we'll say not found, right? Okay, so here we read the file and we get this data, but if there's an error, then we're going to do what? Well, we should probably say status code is, what would be a good status code for if we've experienced an error on our side? It's kind of a 500 error. 500 errors mean that my code on the server screwed up, right? It means that like I've experienced some kind of weird server error and I don't know what to do next. If I can avoid it, I prefer to give a different status code. So for example, if somebody requests something that's not found, a 404 is better. If someone gives me bad input, like if I try to validate their input and the input is not valid, I'll give them a 400, which is bad request. Which means that like the person requesting screwed up, not my server code. My server code is good, right? But in this case, you know, I'm hard coding my file name here. So I expect that that exists. And if it doesn't exist, or if there's an error reading it, then I've screwed up on my server code, right? Something on my server is screwed up. So I think in this case, the appropriate error message probably is 500. And here I'll just say some kind of internal server error happened, right? But I won't tell the user what error happened, right? Because I don't need them to know that, like, you know, I don't know, some file got deleted, whatever. So this is a little bit closer to what Gemma had. I think a switch statement here would be better. But let's see let's see if this works. Okay, so I'll refresh. We got the right file, and if I do this, I get hello world, and if I do this, I get not found. And my not found had the correct status 404. All good, problem solved, right? You know, so it's less efficient in the fact that we have to read the disk during the request, but it's more efficient in the fact that I can have 100 different files and I don't have to load them all into memory right away. But here's what it doesn't solve. There's one big problem yet to be solved, which is what if this file was a movie and it's like 4 gigs of data and I want to send all 4 gigs of data. In this case, I'm doing an fs.read file, which will load the entire 4 gigs into memory and then send it. And maybe our server can handle that, or maybe it can't. Because, you know, it might have 4 gigs of memory, but if there's 10 users trying to request the same movie file, it doesn't have 40 gigs of memory, right? So how could we do this with using less memory? Like, I'm not asking you to know the node way of doing it. I'm just asking you to just think as an engineer, what would be a way that we could serve a big, big file without loading it all into memory? Chunks? Yeah, we could do that. Like, let's not read the whole thing from disk in one chunk. Let's read just a few kilobytes at a time, right? Just small chunks. Yeah? There is actually an abstraction for that called streams. We're gonna use a file stream where we read where we get a stream of data coming in a little bit at a time. And whenever that data gets loaded from the disk into memory, we can flush it to the network. We can send it to the client. One piece of data at a time. That way, if the client's really slow and they can only receive 10 kilobytes per second, we don't have to keep more than 10 kilobytes in memory. Right? You just read 10 kilobytes, send it. Read 10 more, send it. Makes sense, right? So how can we rewrite this to use streaming? There's probably a few ways to do that, but I'll show you kind of the old, ugly way. Most of what we're doing here is the old way. Notice that we're using callbacks, and we're using like these big if-elses, manually setting headers, and there's no caching at all. Yeah, it's just kind of the old way of doing it. There are better ways to do this, but I'm just trying to kind of get you to do it the hard way first, I think. So let's do streaming. Maybe what we could do to make our code a little bit nicer to work with is that what if we split these into different functions? So here, I can move this into serve homepage, right? And then here, I can say serve not found page, which is this part. That might be a little bit easier. But we're still dealing with callbacks and if statements and everything, right? Okay. So let's talk about a file stream. I'm going to move this stuff into another function called serveAsset. And this one will take request, response, and it should take asset path, right? And so or let's call it file path. Something like that. Okay. We could even factor out the 500 error. Serve error page, and this one will be the error. So we could do this. Does that kind of make sense what I did there? Maybe we'll console.error. Okay. File streams. So here's how a file stream works. We say let read stream equals fs.create read stream. And we put in the file path. Now, read stream is what kind of data type? What is it? Buffer. No, it is not a buffer. It is definitely not a buffer. It's a stream, yeah. But the answer I'm looking for is it's an event emitter, like everything in Node.js, right? Everything in Node seems to be some kind of event emitter, right? It emits events, including request is an event emitter, response is an event emitter, server is an event emitter. In this case, what can we do with an event emitter? Yeah, we could add a listener, like on data. So that this is going to get called every time we get a chunk of data. Or how about on error? And this will get called whenever we have an error. So what should I do whenever we receive an error? Call, what do we have here? Serve error page. Let's do that. Okay, so if there's an error, we'll serve the error page. If not, then whenever I get some data, I'm going to comment this out. I don't want to do error handling right now because that gets a little bit complex. But let's just say whenever I receive some data, what do I want to do to the data? Yeah. How do I send it? You just send it through like that, right? What about when the stream is finished? Like, what about when it's ended? Like when the stream is done reading? Just response.end. But we kind of forgot one thing. Where do I put my status code and my set header? Before the end? Yeah. So I have to actually put it before the write. Because after I send the first chunk of data, I can no longer change my status code or my headers because the headers have already done and we're now sending the body. Right? Headers have to come before the body. So I can't start writing my body to the output and then go back and add a header. So my headers have to be done before that. So what if I do it here? So I can say, look, if initially I haven't sent any data yet, right? So sent is false. And then when I get my first chunk of data, I'm going to check, okay, if sent is false, then I'm going to go ahead and write my headers. So we could do that, right? What's another way we could do it? We could be like chunk count. Maybe something like that. Same kind of concept. I don't know, which is more clear? That would work, right? You might think to yourself, well, wait a second, why don't I just send it right here? And then I don't need to keep track of all of this, right? Why don't I just go ahead and send the status code right away? What would be the disadvantage to that? yeah, what if something failed before we got our first chunk? Now I can't really send that error page because I've already sent a 200. As long as there's no errors, this would work, I think. But, you know, we might want to put it inside here, and then I can attach this error handler. I might also want to say, so that way if I have an error, like if for some reason I have an error, just stop sending any more data, right? But I don't think we have to worry about that. I think the stream is smart enough that if it has an error, it won't emit any more data chunks. But these are interesting race conditions that you have to think about if you're building like a really comprehensive, robust system. Does everybody understand now that this read stream is not going to read it all into memory at once? It's going to read one chunk at a time. There is another problem with this. But I won't tell you yet. Let's just see if this works. Okay, so we got the not found. Got the home page. We got the image. Should we send like a really big file to see what happens? What we could do is, I guess we could say,
Like reading your video.
I like that idea. Let's send like a really big file. Here's an 800 meg file. Let's move it to our project folder, and let's put it inside assets. Let's call it video.mp4. Okay, so this time we're going to send, what's the content type for video mp4? I guess it's video mp4. So where's my file? Let's just add another route. This is easy now, because now look, I can add as many routes as I want really easily, right? In fact, I can make this even easier. So just so that I don't need any else, what if I return after each one, right? Does that make sense why that works? So now if I say files video.mp4, I can serve it from assets video.mp4. So I'm reusing my same serve asset function over and over, right? And that's pretty helpful. And the reason I put the return here, it's kind of like the break in the case. We should probably just use a case, right? Switch. That's kind of what this is meant for, I guess. And then what's the last one? Okay, maybe that's better, right? Maybe a little bit clearer. Okay, and so now I can easily add as many paths as I want to, and I don't have to write all of that messy stuff because I factored it into its own function, right? So let's do this. And remember, what I'm looking for is this like console.logoutput sending chunks, right? Okay, so let's get video.mp4. So the browser is going to play this thing. And then over here, I got like all these chunks coming out, right? Like thousands of them. But the good news is it's not loading it all into memory at once. I wonder what the size of each chunk is. How many bytes? Data.length. I forgot to break again. I don't think I have to break after default because we're at the end of the function. If I leave this out, my lint should catch it, right? Okay, let's refresh this thing and see what happens. And all of these chunks are exactly, does anybody know the significance of that number 65536? Yes. 16, 2 to the 16. But actually, more importantly, it's 64 kilobytes. The operating system decides how big of a chunk it wants to read at a time. Maybe it's dependent on the disk or the I/O system. But anyway, it looks like at least on this computer, Node decides it wants to read 64 kilobytes at a time, and that's fine. 64 kilobytes is still less than the size of that JPEG that we read earlier, right? Okay, so there's a problem though. There's a small problem here. Let me give you a moment to see if you can figure it out. I'll give you a hint. So the problem is within this read stream logic. There's a logic problem there.
What if it breaks in the middle?
Like an error or something?
Yeah.
I think we're okay on that because we already added the callback. Okay, so here's the problem. It's called back pressure. So the problem with that is that what if my read stream is much faster than my write stream? And I guess we didn't use the term write stream before, but response is a form of write stream because we can write one chunk at a time to the stream. And as we write it, it will send that data to the browser or client or whatever. The problem is network connections might be a lot slower than reading a file from disk. So if I can read and attempt to write faster than what that write stream can handle, we get something called back pressure, which means eventually, so the operating system will buffer a little bit if the network's kind of slow. The network card itself will buffer a little bit if it's kind of slow. But eventually, all the buffers fill up with data, and we cannot send the data fast enough. And the buffers have all filled up, and we can't just stop the read stream. We can't pause the read stream. Well, we can, but it won't do it automatically. So there is complicated ways to handle that. There's a return value. Okay, so the ideal way would be that response.write is asynchronous or returns a promise, and we just wait for that promise to resolve, right? But that's not how it works. Response.write is always synchronous. So it will always immediately write that data to the buffer in the operating system, and it will immediately return. But it will give us a return value, and that return value will console.log it. I kind of don't want to write 1,000 chunks. Let's do this. So if chunk count is less than 900, then we'll do the console logging stuff. That way I don't have to, I don't want like 10,000 lines on there. Okay, let's do this. Okay, let me try something different. Let me emulate a slower connection. So now it's like emulating a much slower connection, right? Okay, the return value is true if the internal buffer is less than the high water mark. Okay, if false is returned, further attempts to write data should stop. Okay, so if we get false from our write, we should stop writing data. Until when? Until the drain is emitted, meaning the buffer has been drained again. So this gets really tricky, right? So here's what we have to do. If result is false, what would be a better word for the word result? Okay, if should continue is false, then what we want to do is read stream.pause. Then I want to add an event listener. I want to wait for drain. I want to wait for it to drain, and then I want to resume. Okay. There's still a problem with this. This drain thing we're gonna have a lot of drain event listeners added onto this, and I've never removed any event listeners, right? So this is gonna run every time it drains. So I guess I could move this over here. So every time it drains, I want to resume my stream. But actually a better way to do that would be, what if I just say once? So there's another way to say, I want to add an event listener just once. The first time this is finished calling, remove the event listener again. Okay, so I'm going to pause the stream. Once it has drained, I will resume the stream. Should we see how often it pauses and resumes? Okay, let's see how often it pauses and resumes. Okay, let's run this thing. So it's now much slower. Look, we're only on chunk 26. This is easier on my CPU because most of the time is spent paused. It's easier on my disk because I'm not reading writing very often. I'm reading one chunk every 800 milliseconds maybe. And I'm just pausing and waiting, pausing and resuming, pausing and resuming. So this is called flow control in terms of like controlling like the flow of the data. And it's complicated. And there are better ways to do this. But because Node is a little bit old now, I mean, Node came out before we had all these awesome promises and async await. Node exposed this kind of really weird way of like pausing and unpausing our read stream, right? But it works. The good news is there are layers of abstraction that allow us to not have to deal with this. So ultimately what we're doing is we're taking data from one stream and sending it to another stream. That's called piping. We're piping data from one stream to another stream. Is this like pause resume stuff too complicated, or do you kind of understand what's happening there? Drain means like if you have a bucket full of water, if you have a bathtub full of water and you open the drain and all the water drains out. And so in this case, what it means is the buffer has drained. So the buffer is something that at the operating system level, that when I write data to, let's say I want to write data to the network card. You know what I mean by the network card? It's like I want to write it to the network. And so if I send 64 kilobytes of data and I give it to internally to the network device, and my code gives it 64 kilobytes, the network device probably has a buffer. It has some memory chips built in that says, okay, I can take that, I can handle that 64 kilobytes, but I can't send it all at once because the network's kind of slow. You get it? And so eventually I give it another 64 and another 64, and eventually its internal memory has filled up with just data waiting to be sent to the network, right? And so drain is an event that is emitted whenever that buffer has drained back down. A better way to think of it might be something more like you've got a bucket, a data bucket. And this bucket has a hole in the bottom where water is pouring out, right? And water in this analogy is data. Okay, so in this analogy, the water is coming out. But the water is going in, the water's data, remember, at a faster rate than it is going out. So in this analogy, what is the bucket? The bucket is your network device, right? The buffer, right? And so data is coming in here much faster, so then it can leave, so the water starts filling up. And when the water gets to a specific level that we decide that internally is decided by Node or whatever, it says like, look, I'm getting kind of full. Please stop adding more data until I drain again. So in this case, drain means the data is slowly going out. Does that analogy kind of help?
Yep.
Yeah. So anytime you're dealing with streams, you have to think about this kind of stuff, right? Because this is your write stream. The data leaving might be slower than the data coming in, or it could be the other way around, right?
The effect drain will cause
when this water gets
not touch the X, or if it drain or the
I think there's a lower one too. There's like, so X is like the max. Maybe we'll call this max. And then maybe here we have like a min. I mean, it's not really minimum, but anyway. So when the data gets back down to here, then we call drain. Then internally, node will call our drain callback. Does that help? Okay. That's my analogy about streams. So streams are kind of complicated. But anytime something in computer science is kind of complicated like that, we create a layer of abstraction. Do you know what I mean when I say a layer of abstraction? Like in its simplest form, the simplest way of thinking about it is that we created a layer of abstraction whenever we created this serve error page. I mean, in this case, it's just a helper function. A helper function is kind of like an abstraction. Because now, I create this thing once, and I use it inside of a lot of other places, and I don't, like inside of here, the programmer who's writing this function doesn't have to care about how the server error page works. We just know that it works, and we can call that function, right? And so I would call, like this is the simplest kind of layer of abstraction, is just helper functions. But sometimes when you get to really complex topics like data streams, you want to create better layers of abstraction. And so in this case, we want to create a way to generic way to pipe data from a read stream to a write stream. And that function is already built into the language, not the language, but it's built into Node. But I'm going to ask you to create it anyway. It'll be fun. So the goal is you want to create a function called pipe. And what pipe does is it takes a read stream and a write stream. And it takes data from the read stream and sends it to the write stream. Does that make sense? Does anybody need to screenshot this code right here before we continue? I don't want to paste it to you because I want you to actually write your own code, but if you need to screenshot this just so you can go back and look, that's great. Keep in mind, you cannot assume that a write stream has anything like set headers, because set header is not on, like that is not available with a generic write stream, correct? A generic write stream only has write, has this drain event, and it has this end. Where's end? So a generic write stream doesn't have like status code, set header stuff, whatever. But that's fine. Don't worry too much about that. In fact, to make things simpler, I'm okay if we just move all of this outside of here to make things simpler. So the goal is, what I want you to be able to do is, I want you to be able to say, pipe, what? What's my read stream? Whoa, read stream. And then what's my write stream? What is it? It's just response. Response is a form of write stream. And then this becomes much simpler. Do you think you can create that? If you can understand streams well enough to create a pipe function, then you totally understand this more than most developers.